Look up at the night sky. What you see is a canvas painted with light. Every star, every galaxy, every nebula, they whisper the story of a cosmos that is immense, beautiful, and seemingly complete. We are made of that light. The oxygen we breathe, the carbon in our bones, the iron in our blood, all forged in the hearts of distant, dying stars. This is the observable universe, the part we know, the part we can touch. But what if that magnificent picture is a lie? What if everything we have ever understood, the planets, the stars, the brilliant galaxies, is merely a thin, luminous veneer on something vast, invisible, and terrifyingly unknown? Scientists have reached a sobering conclusion. Everything you see, everything that interacts with light and energy, the normal matter, makes up less than 5% of the entire universe. Where is the rest? 95% of our reality is missing, hidden in the shadows of the cosmic web. Our deepest search for answers leads us to two fundamental, invisible forces: dark matter and dark energy. Dark matter is the first piece of the puzzle. It does not emit, absorb, or reflect light. It is truly dark, utterly transparent to our telescopes. Yet we know it exists because of its profound influence on the movement of the things we can see. The story begins in the 1930s with the Swiss astronomer Fritz Zwicky. Zwicky was studying the Coma cluster, a massive collection of over 1,000 galaxies bound together by gravity. As he analyzed the speed at which these galaxies were moving, he realized something was fundamentally wrong. Based on the visible light they emitted, the combined mass of their stars, the galaxies should have been moving slowly, slow enough for the cluster's gravity to hold them together. Instead, they were hurtling around the cluster's center with such incredible speed that the entire structure should have flown apart billions of years ago. To explain why the cluster hadn't disintegrated, Zwicky argued that there must be an enormous amount of unseen mass, a cosmic glue, providing the extra gravitational pull needed to keep the galaxies in check. He termed this missing mass Dunkle Materie, or dark matter. Decades later, in the 1970s, astronomer Vera Rubin provided the undeniable proof that would change astronomy forever. She was studying the rotation of individual spiral galaxies, specifically the Andromeda Galaxy. According to the laws of Newtonian physics, stars on the outer edges of a galaxy should orbit slower than those near the center. The farther out you go, the weaker the gravity, and the slower you should move. But Rubin found the exact opposite. The stars on the outer edges of the galaxy were orbiting just as fast as those near the center. They were moving so fast that they should have been flung out into deep space. Something was holding them in. Rubin realized that the galaxy was embedded in a vast, invisible halo of mass, a dark matter halo. This halo contained 10 times more mass than all the visible stars combined. So the evidence for dark matter is overwhelming. It is the necessary cosmic glue. But what is it? We know it is not ordinary normal matter. If it were clouds of gas or dust, it would absorb light. Dark matter must be composed of something entirely new, something beyond the standard model of particle physics. The leading theory points to WIMPs, or weakly interacting massive particles. These are subatomic particles that ghost through normal matter as if it wasn't there. Billions of them are passing through your body every second, yet they never interact with your atoms. To catch one, scientists have built laboratories deep underground, like Xenon 1T in Italy, shielded beneath miles of rock to block cosmic radiation. Inside, huge tanks of liquid xenon wait for a single dark matter particle to create a tiny flash of light. So far, the detectors have remained frustratingly silent. While the direct search continues, we can see dark matter's organizing power on the largest possible scales. Supercomputer simulations show that the entire universe is structured like a giant, three-dimensional spider web, the cosmic web. The invisible filaments of dark matter act as the scaffolding for this web. Normal matter flows along these dark filaments like water, pooling in the densest knots to form galaxies. Without dark matter, the universe would be a uniform, lifeless soup. It is the architect of the cosmos, We all dream of a power greater than the command of stars or the splitting of atoms, the ability to command time itself, to step back into the past and witness history unfold, or to leap forward and glimpse the destiny of humanity. For most of human existence, time has been viewed as an absolute, unchanging river, flowing relentlessly in one direction, a rigid arrow moving from the fixed past toward an uncertain future. We are prisoners trapped in the present moment, carried along by the current, unable to speed it up, slow it down, or reverse its course. But what if this perception is merely an illusion? What if time is not a straight arrow, but a complex four-dimensional landscape that can be bent, twisted, and perhaps even folded back on itself? For centuries, this idea belonged solely to the realm of fantasy, until one brilliant mind changed everything we thought we knew about reality. In the early 20th century, Albert Einstein shattered our comfortable view of the universe. He taught us that time is not absolute. It is relative. It is malleable. And the secret to unlocking it lies in the nature of light and gravity. The story of scientifically proven time travel begins with Einstein's special theory of relativity in 1905. Einstein realized that space and time are not separate entities, but are woven together into a single, flexible fabric called space-time. And crucially, the speed at which you move through space affects the speed at which you move through time. There is a cosmic speed limit, the speed of light. Nothing with mass can ever reach it. As you approach this limit, strange things begin to happen. Time, for you, begins to slow down relative to someone standing still. This phenomenon is known as time dilation. It is not a theory. It is a proven fact of physics. Imagine an astronaut who boards a futuristic spacecraft capable of traveling at 99.9% of the speed of light. They set off on a journey to a nearby star and return to Earth. For the astronaut on board, the round trip might feel like it took only 1 year. They have aged only 12 months. But when they step out of their capsule back on Earth, they would find a shocking reality. While 1 year passed for them, decades, perhaps a century, would have passed for everyone else. They would return to a world where everyone they knew was long gone. They have effectively traveled into the future. This form of time travel happens every single day. The GPS satellites orbiting the Earth move faster than clocks on the ground, and because of their speed, time ticks slightly slower for them. Engineers must constantly adjust their onboard clocks to account for this tiny amount of time travel. Otherwise, the entire GPS system would crash within a day. We are already time travelers. We just haven't built a fast enough ship to notice it yet. But speed is not the only way to bend time. 10 years after his first breakthrough, Einstein published his general theory of relativity, revealing that gravity also warps time. Gravity is not a mysterious pull. It is the curving of space-time caused by mass. The heavier an object, the deeper the curve it creates, and the slower time moves near it. A clock on the surface of Jupiter ticks slower than a clock on Earth. But to see a dramatic effect, we need gravity on a cosmic scale. We need a black hole. The gravitational pull near the event horizon of a supermassive black hole is so intense that it severely warps the fabric of reality. If you were to orbit just outside the point of no return of such a monster, time would slow to a crawl compared to the outside universe. A few hours spent orbiting a black hole could equal years or decades back on Earth. It is a one-way ticket to the future, powered by the most destructive objects in the cosmos. So, science tells us unequivocally that travel to the future is possible. It is merely a colossal engineering challenge. The real problem, the concept that keeps physicists awake at night, is traveling backward. Going back to the past is vastly more complicated because it seems to violate the fundamental rules of cause and effect. To travel backward, you don't just need to slow time down. You need to break the structure of space-time itself. Einstein's equations do provide a theoretical possibility for this, a cosmic shortcut known as a wormhole. A wormhole is a hypothetical tunnel connecting two distant points in space and time. Imagine drawing two dots on a piece of paper to represent where you are now and where you were yesterday. The shortest distance is a straight line, but if you fold the paper so the two dots touch, you can step instantly from one to the other. That is a wormhole.